So today, as you probably have joined this session based on the stuff that we talked about on LinkedIn leading up to this, is mastering agentic applications. It's sort of a subtitle to this post is leveraging existing APIs and business functions to build agentic apps with a product called Arch. We'll get in that in a bit. But why even get started with agentic applications? What are those? And how should we think about them as we build new user experiences to delight customers? I'll go in my background in just a bit, but the essence of any new application paradigm is to be able to take tools and technologies to solve user problems that were not easy to solve before. And I'll give you a very clear, simple example. Imagine you are on a website which has a menu item on the left, very traditional point and shoot click website, a SaaS website, and you have to actually get work done. The work that you have to get done could be, resolving a ticket queue, could be answering customer support queries. But imagine you're going through and beeping and bopping between these various sections of a website, navigating your different portions to complete your work done. Agentic applications represent a complete shift in that paradigm of moving away from point shoot, moving away from drop downs and form filling to truly natural language experiences that can enable people to do work. So I'm very excited to be here today to talk about mastering agentic applications and defining what those look like, how you should go think about them, what are the building blocks, but a bit about me. I won't spend too much time here because that's not the most interesting part of this webinar. My name is Salman. I'm the co-founder and CEO of Karanemu Labs. We describe ourselves as a company that operates at the intersection of infrastructure and LLMs and science, really, where we are building capabilities that enable developers to move faster. So they can focus on core business objectives, not the pesky heavy lifting in building smart, enterprise-ready agentic applications for their customers. I was an ex-general manager at AWS, spent a lot of time there, about 8 years at Amazon Web Services, building large-scale distributed systems and services for developers. I also led at Oracle Cloud Infrastructure, half of the North America business for Oracle Cloud. Had an exceptional privilege to touch enterprise customers, being able to work through a lot of the modernization efforts that Oracle Cloud was happening. And so about 20 plus years in building large-scale durable infrastructure software and tools for developers and enterprises. And today, I'm leading a team of PhD scientists, infrastructure developers, and my co-founder, Adil, I think, who might be joining this webinar as well, folks from Meta and Microsoft and Amazon to reimagine the infrastructure and tools needed to be successful in building agentic applications. I can go through a full list of slides. I asked Nabia as well, I was like, how about we build motivation to the end of this entire webinar by looking at a demo where we can actually see an agentic experience, see what the user experience looks like, and work backwards from that demo to be able to outline the full agenda for the webinar. So I'll skip out of this presentation mode for just a second. And I'll start sharing again. And Nabia, could you confirm you're seeing a Firefox page, please?
Yes, we are.
Okay, perfect. All right, so this is a simple illustration which will cover a lot of the concepts we talk about doing a webinar. And this is a agentic experience, as I like to describe it, and we'll walk you through a few scenarios, and then I'll anchor this demo in the remaining parts of the webinar. So let's ask this particular agent what it can do for us. All right, so in this particular case, I asked the agent, can you tell me what you can do for me? He said, sure, I can provide you device statistics for a specific device for a given time frame. So this looks like it's networking devices that it could provide me some statistics for. I'll ask it, give me network statistics. Let's see what it does. So the first thing it did, it would ask for a clarifying question. May I know the device identifier and the time frame for which you want the statistics, which is a core part of agentic applications, clarifying the task for the user and being able to then trigger action, take control over the user experience by providing an action-oriented experience. So I can say device ID 1234. I'll just make something up. and let pass 4 days. So now when it goes, it will retrieve statistics for the last 4 days for a very particular device. Now, in this particular example, what I'm trying to demonstrate is clarifying questions, being able to get statistics for a particular device, and then have the agent be able to do background jobs so that it can display these things at a later time, when I log. In this particular case, it will actually send me an email, and I'll show that to you in a second. Separately, I can ask for it, could you reboot device 1, 2, 3, 4 for me? Sure, device 1, 2, 3, 4. And in this case, it actually went and took an action. So these are some very high-level components I want to talk about as I set the stage up for building agentic experiences. Being able to identify the tasks the users are asking for, being able to clarify the questions, gather input from users, and be able to complete an action all using natural language experience. This is, of course, a bit of an illustration. I'll walk you through the code at the end, but this hopefully gets a setup of the different things you will see throughout this webinar leading up to how we were able to get this experience going. So I'll stop sharing this part of it. Of course, happy to take questions as we go through the meeting, but I'll stop sharing this part of it and get back to my keynote presentation. Okay. All right. Please let me know if you can see the screen as well.
We can.
Okay, perfect. So throughout the webinar, we'll cover key topics. What is agentic AI? When to build agentic applications, the various patterns that we are seeing with our customers and across the industry on how to implement agentic applications, the building blocks of an agentic application, the architecture of an agentic application, and then a functional demo. This was a lightweight demo that I showed just now, but a full functional demo where we can actually use some tools and technologies to be able to create for an agentic experience. All right, agentic AI. It's on top of everybody's mind. Everyone's talking about it. But one of the things that I feel as people talk about this new technology is they probably have gotten a lot of the definitions confused by different vendors. Meaning everyone's trying to have a hold of the definition. And I like to describe agentic AI that operates on a spectrum. Oops, let me just make sure that it's in full play mode, sorry. And operates on a spectrum. On a spectrum of agency. So you have QA systems today, the RAG systems, where you can do retrieval based on a query. You ask the large language model to summarize the answer, or perhaps do some lightweight dialogue over a piece of analytics. And then you move across the spectrum to give the agentic application more and more agency. And as you give more agency, you'll see that it can help users get work done via natural language. An experience that I just kind of demonstrated for you. It was able to reboot a network device. And then you can give it full agency, defining really high-level goals, let the LLM break them into tasks, execute the task, and then course correct. Agentic AI operates on a spectrum. And that's important to understand because you can get locked into thinking that you need to build an agentic application and it has to be in a very specific shape and form, when in fact, it operates on a spectrum. And if you look at the spectrum, you can start seeing this patterns by which you can apply this technology to improve the user experience. Ultimately, the goal of any technology is to solve problems and improve the user experience from prior days where the technology was not sufficient enough to solve the problems. And I gave you the example. Imagine you're going from a point-and-shoot website where you have to click different menu items, fill out various different forms, see different dashboards to complete your job. It's work. It's beeping and bopping between different screens. And now with large language models and agentic AI, you can compress that user experience and offer a delightful natural language experience on a spectrum. You can answer questions accurately, be able to get work done via natural language, or you can, for open-ended questions, and we'll go over that in a second, define high-level goals and let the LLM break down into tasks, execute the task and course correct. I'll walk you through all of these scenarios in the next set of slides. But essentially, there's a bit of additional breakdown into categories that I wanted to talk about. Agentic AI, which is mostly the thing that we will cover today, has more agency or complete agency, can be subcategorized into workflows or purely just known as autonomous agents, where they have autonomy. But everything else in this entire chart, this visual that you see, I'd like for you to leave with this idea that we're operating on a spectrum, and then the agentic AI covers a core set of that spectrum, whether we're talking about fully autonomous agents, AI agents, or agents that are agentic AI that is more workflow driven and more driven by procedural code, both of which are considered agentic AI. If you will take questions at the end, and for sure, please make sure that you jot down the questions that you may have for me. But once you have these definitions, we can start identifying patterns. And so the next few slides, I'd like to walk you through a few patterns and how to think about building agentic AI applications. All right, the first pattern, very common that we see across our customers, across the industry, is this pattern called routing. Essentially, what it means is you have a really good understanding of the user tasks that you are trying to go build, and that you will use an LLM router in the middle, in the front, to be able to direct calls to other LLMs to complete an outcome for the user. This is an agentic pattern. This is a pattern also published by Anthropic. And so there's a lot of commonality in what we're saying here with what some of the industry leaders talk about as well. So the agentic pattern here is called routing. This is one of the, in order to master agentic AI applications, you need to understand the patterns. In this particular case, it's super useful where your agentic AI application, a single pane of glass, is directing different type of customer service queries, general questions, refund requests, technical support to downstream processes, prompts, and tools. Once again, if you have a user experience that you want to build supported by the natural language interface, you'll have to think about the work that users will present to your application, agentic application. It could be in the form of highly accurate retrieval. It could be also in the form of being able to trigger and get work done, useful work done. For example, be able to ask for a refund request on a product item that someone purchased, be able to get technical support on a product that someone is using. And that pattern is becoming a very predominant pattern and being able to improve overall accuracy and the responsiveness of the user experience, because now you have segmented out your application to more clearer tasks. And in some cases, this pattern may not apply, and we'll talk about that too. Well, the other particular usefulness of this pattern in building agentic AI is routing easy queries to a smaller model, a more lighter, cheaper model, or the hard and usual questions to a more capable model. As you think about building agentic AI applications, you'll have to start thinking about how these patterns fit into the user experience that you want to go build. The other pattern that we see a lot from our customers and across the industry as well is chaining, where one LLM call outputs to a gate, we'll talk about that in a second, and then passes that information to another LLM call or multiple LLM calls. This is a bit of a workflow. This is what I described a couple of slides ago. But imagine you're generating marketing copy, and then you're translating that to different languages. Guess what? It's chaining one call to the other call. Your gate could be, hey, the first marketing copy that was generated was not good enough. You ran some evaluations and you determined that was not good enough. And you can fail and exit out there. But this is a very important pattern to be able to build high quality systems. If you have a few steps you have to get done before you can actually send something to the user. And the other example could be writing an outline of a document and checking if the outline meets a certain criteria. There are a few other types of patterns that fall more in the workflow category of agentic AI. I don't think we'll have time to cover all of them. There's orchestration patterns that you may want to be familiar with, but these are the more common scenarios that we are seeing with our customers and across the industry, where they're trying to accomplish tasks and outcomes that are agentic in nature, but essentially more workflow driven. The other pattern, which I think is worth talking about and perhaps requires some time, is autonomous. These are augmented large language models that have access to your environment via tools, functions, and APIs, and they are deciding the end state given a high-level goal. You may all have heard of OpenAI Deep Research most recently. OpenAI Deep Research is a type of an agent that enables you to do research. Deep research, I think they named the product pretty well. And what it does is you give it a high-level goal. Imagine you're researching a vendor before you select them, or a set of vendors before you select them to do work, or you're researching a competitor. And then the actual the agent itself needs to figure out how it's going to break down and decompose the high-level goal, run various steps via planning, access your environment for up-to-date information if needed, or up-to-date information on the web. That's also an environment. And then use that as a feedback loop to come to an end state. These are highly, highly complex, but very useful agentic patterns if the problem is truly open-ended. And I think the three different use cases, whether it's routing, chaining, or autonomous, and both are workflows, or autonomous agents, we all have to think through how do these patterns apply to the end goal, the problem that we are solving on behalf of our customers and users when building agentic applications. So this is a very powerful way to do this. The challenge becomes you're trading off latency, cost, to be able to take an unbounded, open-ended problem and provide a good user experience. Deep research is one of those examples. Obviously, deep research costs an incredible amount of money to use, but in some scenarios, in an organization, you can imagine there's some higher level executives that need to do workforce planning. And they need to know what should they do as they navigate the world where there are more tariffs and there are going to be more legal restrictions in different parts of the world. How should they go about thinking about workforce planning? That scenario is an open-ended problem. So there are a few additional patterns. I don't think we will have all the time to cover those patterns, but I want to sort of start recapping from the beginning up to these patterns because we'll get into the nuts and bolts in a second. Building agentic AI means understanding across the spectrum on agency, where do we want to fit in to solve a user problem? Being able to build agentic applications means you can now offer a user experience that was never applicable before. You couldn't do it without this technology. But applying the right technology, the right level of agency, and using the right type of agentic patterns to solve a customer problem is super important, because then you have a sense of how to go about using the building blocks to create that experience that you want to create. Whether it's task-based routing, whether it's prompt chaining, or autonomous agents. So this is a good segue into some of the conversations around building blocks of agentic AI. And I've kind of put them in full buckets. We'll talk about them at length because this is a place we have to anchor some of the conversation. I'm sure you'll probably have questions based on this slide as well. But this is important because you'll have to sort of look and piecemeal, what does it mean to now build agentic AI when you have seen the patterns, when you've seen the use cases? And then you can start matching to saying, what do I need to be able to accomplish that? So at first, on the left-hand side, top left, I talk about configuration. Essentially, these are things that you should start thinking about that have very little relation to application code. Your goal definition. What are the types of goals and tasks via system prompts would you want to support in your application? What are the guardrails and safety checks? Can your agent be able to search up your competitor in that same experience? That's your choice. What kind of guardrails of safety rules do you want to apply using configuration that guard the overall agentic application? What type of large language models would you want to use for certain select scenarios? For example, some of our customers use Gemini 2.0 for video creation, but they use Claude for structured output and document creation. Knowing how to use these large language models and where they would fit in your agentic task definition and usage scenarios are super important. If you get this wrong, you will tend to want to spend cycles and try to figure out how to get this right. But I start here because it's super important to know what are the basic structure of your agentic application. Move to the right, top right, we'll go to application code. There are three key things, I think, amongst a lot of business logic piece, I think, deeply. Task clarification. If the user asks you to do something, have they offered you enough clarity to be able to complete that task? Your applications need to be able to now take the overall goal definition, see if the user prompts matches to that goal definition, use models or other technologies, tools and technologies to clarify the task. This will improve the user experience because if you get your output wrong by assuming a whole bunch of things, then you've wasted time, cycles, and overall user experience to have fixed that problem up front. And so you have to think about building that task clarity so that you can solve the problem fast, quickly, and efficiently on behalf of the user. By task, I really mean the goal. You could have a goal to be able to, as I said, open up a ticket in ServiceNow or Asana. In order to do that, you could ask some details. Hey, what is it for? So if you understand the task really well, you have your goals defined, then you have to be able to get clarity on those tasks so you can take action or perform that task appropriately. We'll dive deep into function calling in the next slide, but it's super important. That's the environment. What do you make available to the large language model or the set of tooling so that it can actually complete tasks in your environment or retrieve information that help it complete tasks that the user has specified? And last but not least, using the right SDK, using the right frameworks for simplicity, not necessarily for abstraction, so that you can move faster. Those are the core building blocks that you take into application code. They're business logic related. They're not infrastructure related. On the bottom left, it's measurement. I think it's super underrated today that evaluations are not a core part of everybody's building stack as much as they should be. Benchmark performance of a large language model or benchmark performance of a particular agentic AI is not useful because it's not solving a task that you have designed for your users. Being able to build offline, online evaluations of the user experience, it could be through LLM as judges. We'll talk about that in a second. Human feedback, we'll talk about that in a second too. But essentially, if you don't have evaluation of how well your user experience was, did you answer the question? Did you get the task right? Did you complete the task on time with the right level of accuracy? You'll have to run a few simulations, but you'll have to think about evaluation as a core part of the measurement of your user experience. And how would you then use that information to improve your system prompt, to improve your task clarification, to improve your function calling, to improve your choice of LLMs? All of that hinges on evaluations. The other important things are traces and metrics and logs, being able to see and debug issues when they happen, versus having to now figure all that out once a user reports an issue that you don't know where to get started. Having metrics on latency, having metrics on time for output token, having logs and traces for both the prompts that are incoming and the calls that you're making to a large language model to connect the full sequence of user experience is super important to be able to improve the user experience. Agentic AI hinges on you defining the tasks and evaluating how well your applications do against those tasks. Without evaluations and traces and metrics and logs, you will be running in the wild and you wouldn't know if you're truly offering a good user experience or not. Last to the right, and this is, of course, some of this is a bit of a simplified version, but they're infrastructure and tools. And I've separated that out from application code. Infrastructure and tools are things that help you move faster without you having to rewrite, recreate, remaster core capabilities that you need to build a highly accurate agentic application in your application code. And so things such as you may have heard of a vector database, the ability to store embeddings and representations of text in a different format. So when you do retrieval, you can extract those embeddings from a vector database that's designed for fast retrieval and indexing and storage, and use that as a means to improve the context for the large language model to answer questions. So vector databases are super important. The other important category, which is emerging, is a prompt gateway. Being ability to dispatch calls and incorporate different large language models quickly, get tracing and metrics out of the box, apply guardrails at the perimeter and at the edge, being able to route to the right task definition inside your application code enables you to move faster by focusing more and more on the application code, the things that define your user experience along with your configuration. And last but not least is memory. In order for you to build a delightful user experience, you need to be able to know how much of the context from the user chat history, how much of the context from recent queries do you want to actually be able to get to serve and in solving that task or the user query that you just got from the chatbot or other means. And memory is a newer field, very nascent field, but important for you to think about how would you be able to extract the right context, store it for fast retrieval. Next time a similar question comes or related question comes, you're able to extract things from memory pretty quickly and present them to the large language model along that as being the context, and then being able to then take the query and then solve the user's ask, whether that's a retrieval ask, an agentic one via workflows, or truly as part of your autonomous agent development. All right, so one particular one that I want to get more detail on from this list is function calling. This is business logic. This is application code that you define, which truly dictates the full experience for an agentic application. Why? Because it means these are core pieces and building blocks that you expose to the large language model, expose to the tooling that help the experience be deeply personalized to your domain. Now, we didn't talk a whole bunch about fine-tuning LLMs in agentic scenarios. I don't think this is that level of, say, 200 level course where I would go into that details, but this is an exceptional start to being able to build highly accurate, domain-specific, personalized applications. And so what is function calling? It enables models to fetch data and take action. If you look at the description that I shared, where we talked about agentic AI on a spectrum, where you go from little agency to more agency to extreme agency, if you would, being able to help users answer a question and complete a job for them is the action. Now, fetching data, basically it is retrieving up-to-date information to incorporate into the model's response. Some of you may be familiar with RAG, so I'm not sure how deep we want to get into that. And in that particular case, it's used for searching knowledge bases, databases, getting accurate data as the user may ask for it, and then being able to summarize across that data. But that's the context. But taking actions, performing actions like submitting a form, calling an API, modifying some application state, or handing off the conversation to another agentic application that is designed to handle that task, essentially routing. Function calling is essentially taking your business functions, the ones that are public or private, and exposing that functionality in a structured way to the large language model so it can use that type of information to improve task performance, get work done, and retrieve more accurate, contextual, domain-specific data that it wouldn't have been able to get otherwise. Your data, your application state, or things that you are building are very unique to your situation. Some medical records are not in the public domain. And some insurance records or insurance policies that need to be pulled at if some user is building, trying to shop for insurance quotes. Their insurance policy, their past deductibles, their past claims will all be retrieved through function calling, a building block in creating agentic AI. Okay, I'll pause here for a second because I do want to get into more of the nuts and bolts and show you some scenarios. So a bit of a recap. Agentic AI operates at a spectrum. There are various patterns that you should get familiar with. And I think, Navia, we should send out a link to the folks on some of the patterns that so it's easy for them to consume along with this webinar. Being able to look at those patterns, seeing how they fit to the user experience you want to go build. Look at the building blocks available, application code, business logic, infrastructure, tools, configuration, and choosing the right models and measuring your outcomes. And of course, we went dive deep into function calling, but essentially being able to take all that saying, now how do I get started? It's a crash course in mastering agentic AI, but essentially, one of the things that I wanted to show and showcase today is you can move the needle forward in a major way with a few function definitions and some configuration. So I'll get out of presentation mode and I'll walk you through a user experience with simple Python code and some configuration as related to Arch Gateway. And that will be a segue into talking about this, where you can use the combination of some function definitions and some config to create and power an agentic experience. That experience, which doesn't have full autonomy, has more of, but to be able to complete a user's action, take action, like reboot a network device, retrieve network statistics, etc. The demo that I started at the beginning, but I'll start walking you through some code, walking you through some config, and then put it together and run the demo again. So let me get out of this mode, and then we'll take about 5 to 10 minutes spending in sort of the weeds of it, and then we'll pop back up to take questions. This is, of course, a first session and to lay the basic foundational thinking of what is an agentic AI application. But it should, hopefully it's helpful as you start seeing some of it in an action. So I'm going to pop out of here. And Nabia, you have to keep me honest if you're seeing the right screen, okay? Because I need to start sharing that now.
Yeah,
Okay.
sure.
All right. Let me
Yes,
know if
I
you guys
can
are
see it.
seeing. Okay, perfect. Awesome. All right. So I had walked everybody through in the beginning through some basic code, basic user experience for an agentic application. 2 specific tasks: rebooting a network device, as seen here, or getting device summary, the network statistics. If you look at that's total 93 lines of code. These are essentially function calls that you define using standard, very traditional mechanisms in Python using pedantic, FastAPI of the sort. And this is, of course, an illustration. It's not actually looking up stuff in a database, not actually triggering a full device reboot, But essentially what this tries to emulate is how this would work if this was connected to a database or an actual network device. So a reboot network device is a function call, as I mentioned. Getting device summary is a function call. And these types of capabilities now need to be exposed to an agentic experience where the user can, in natural language terms, ask this agentic AI application some questions, and they need to be able to route to these function calls to be able to get precise data or take action, and then return from them and summarize their response for the user. So that's part one. Part one is just looking at some application code. If you're a Python developer, if you are a machine learning developer, this should be fairly straightforward in terms of looking at the code structure, not the actual implementation. We'll walk through that in a second. The second piece is this configuration. I mean, if you remember, I talked about configuration being separate from application code, because then you can make configuration changes outside of application code and be able to decouple these things to move faster. So this is a YAML file. There's a JSON variant of it as well. For Python developers and JavaScript developers, they don't particularly like YAML, as we've learned. But essentially, this YAML configuration file defines a set of LLMs, their access rules, their retry policies, the type of models you want to use, defines a set of system prompts, the goals and the tasks that you would want to complete, and defines essentially as a high-level abstraction on function calling, thing called prompt targets, what targets to trigger based on the natural language representation of the user's ask. In this case, device summary is essentially a maps to the device summary API that you've defined here, which takes in a device summary request, and which essentially has a device ID and a time range. And the idea here is capturing all of that in configuration, so you can separate out business logic from your configuration code, be able to now map to the user experience you want to create. And in this particular instance, we only have two prompt targets, essentially high-level abstractions of function calling. And you only want to support summarization of device statistics or rebooting a network device. You could, and in each one of those scenarios, you can further define the goal and specific summarization system prompt. But that's a more detail that I want to cover into. But essentially, configuration, as I talked about, application code, as I talked about, and then, well, let's rerun that experience. Let's rerun the experience to see how we would take very simple traditional business logic, using some configuration packed into Arch Gateway. It will basically unpeel Arch Gateway through this experience, and then just rerun the demo. Okay, I'm going to stop sharing here, and I'll go back to my desktop again. Give me a second. All right, it's coming up. Good. 1 second. Sorry for the share delay. All right, share delay. Here we go. Okay, Nadia, can you please confirm you can see the screen?
Yes, I can.
Okay. So this is now a running application backed by that config and backed by the simple two API that you saw in Python. As you can see, the first thing the user asks is, can you tell me what you can do for me? And it, without actually hitting your backend, without actually doing any additional details, it gives you an exact answer of what it can do for you. It can help you with a variety of tasks. It can provide you with network statistics, or it can help you reboot a device. Guess where did we see those things? Those are the things that we configured as part of the configuration of your application using Arch Gateway to tell it that, hey, you need to be able to keep it to these types of tasks. But that's what you're supporting. You're not supporting someone searching up, shoes and do shoes research between Nike and Reebok. But it says, okay, I can help you with these two scenarios. The next step is, can you get me network statistics. Let's imagine that we ask this question. It says, in order for me to get you statistics, can you please specify the device ID? This is once again a clarifying question. Note in this case, again, you did not have to write this piece of code. Part of that was packed into Arch Gateway. And I'm peeling out some of the functionality here, as it's one of the leading prompt gateways in the market. And then you say, okay, sure. Device ID 12335. Sure. And then I'll walk you through a bit of a trace. See what happens here. It says, I've now, the user has clarified the task and provided all the relevant inputs. And if you see, there's a summarization that's happening here. How did that happen? This is perhaps good to show you the measurement portion of building an agentic AI. I'll load this up. Just give me a second. These are traces and logs. And what I want to show in this case is what happened in how when this particular last request came in, what happened. And the traces are super helpful to understand what happened. Now, obviously, Arch Gateway pipes into standard-based open telemetry traces and metrics and logs, so you don't have to build that logic yourself. But in this case, there's an ingress, which is the input from the user. This is the time that it took for the Arch Gateway to process the request, about 410 milliseconds in this case. It forwarded that particular request. This is the get me network statistics request to the app server. The app server was in main.py. If you remember, device summary was one of the Python functions that we had exposed via the config. And then it actually dispatches the final call to the LLM provider configured in the config file to summarize the response, which took about 2.1 seconds total. And that's the experience that you just saw. What I can say to it now, can you reboot a device for me? Is I'll ask for a device again, because which one do you want to reboot? 34134. I'll just give it and make up any, because an illustration, the request to reboot device 311 was successful. Once again, let's go back to our metrics. Look at our traces. This is the second call being made in which where I clarified the question, device 333134. There was an inbound call to the Arch Gateway, which called the API server in a very specific process, device reboot. It detected that the user wanted to do a device reboot, called the device reboot function, took the response from that function, and then triggered a large language model call for summarization as a convenience feature, which took about 1.52 seconds. So all in all, this entire agentic experience where it has more agency, doesn't have full autonomy, was being able to build in 93 lines of code in a subconfig file. And just to go back to the config file to show to the audience, is to tie it all in. The device summary question, when I asked, can you get me network statistics, mapped to a device summary prompt target. The device reboot scenario, user request mapped to the device reboot prompt target. And then the convenience features built into Arch Gateway triggered the large language model calls based on the response that we got back from the application code, the function calls. All right, 5 more minutes and then we'll take questions for sure. Quickly, I'll just go through a bit of a description of the product because we've backed into it in some ways. I can't share. 1 second. Trying to figure out how. Okay, here we go. Okay. Once again, Nabil, you've got to keep me honest if you can see my screen now.
I can see your screen.
All right, so we talked about now a product, which is part of the component in building agentic AI applications, Arch Gateway. An AI native Edge and LLM gateway server for agentic apps The essence is you have application code, and then you have infrastructure and tools. And infrastructure tools like vector databases and memory APIs tend to handle the pesky heavy lifting, so you can move quickly. And essentially, this is where it sits in the stack. You have a human chatting with some interface. Arch Gateway, with purpose-designed fast large language models, does two tasks. Clarifies a question on behalf of the user based on the configuration provided, extracts structured data, information like entities, relations, from the user query, and passes that to your application server and asks it to complete the task. Once it receives a response based on convenience features, it can simply dispatch the summarization call to one or many more large language models configured using a unified interface, and starts logging metrics and traces in metric stores like Jaeger, Signos, Honeycomb Bio, additionally, any other open telemetry based, so that you can start moving faster and thinking and building about agentic scenarios. The more future work that we're doing at the moment is supporting full autonomous scenarios, where essentially the Arch Gateway becomes a router to different autonomous agents, does quick task clarification questions before it presents to the agent the full query. Just think of it as a companion to a professor, like a TA to a professor in that scenario, and then be able to do effectively handle these things outside of application code. So you're focusing on more high-level objectives, not the nitty-gritty, pesky details of prompt engineering, user query parsing, intent detection, routing, etc. So that's essentially it for today. I think we already did the demo. So what I want to do now is just get to Q&A. We are about 10:50, which is where I wanted to pause and take questions from the group as they come into chat or otherwise. Okay, what's the question? What is the best API to use for example, seeing as OpenAI is expensive for most of us? It's a good question, Geraldine. I think you should look at task performance, not just token cost first. Task performance is essentially knowing what you're trying to solve for. What's the user experience? And then I think this is why choice of having multiple large language models and having an evaluation suite is super important. If you want fast inference, and if you think your tasks are simple and generally easy to solve for, yeah, absolutely use Grok or other APIs. But there are certain scenarios like in creative writing that GPT just performs exceptionally well. That's both through anecdotes and through what I've heard from our customers. And then Claude for structured writing, structured output, exceptionally well. But one of the key parts of the innovation in Arch Gateway is being able to take the user goal and route it to the right large language model without having you to figure that part out. So that's a feature enhancement, a feature that we're building at the moment. Next question is, I suppose the demo exceeds the realm of security, but it's an interesting thought experiment to ensure authorization for these. For sure. Authorization, there is bare authorization support today that we didn't demonstrate. So security like guardrails are applied at the gateway. You can apply additional authorization rules as well. So all of that is so that you don't have to figure all that part of an application code. So it is one of the core capabilities. We just didn't highlight it for this particular session. There was a lot to cover in terms of patterns. How do we define agentic AI that we felt that could be a future session. I assume the tuning go, no go decision falls on the choose LLM task. I think so. I think essentially choosing a large language model or the right type of model for your task depends essentially on the goals you want to achieve. Once again, I started the whole conversation on mastering agentic AI is first mastering what are the problems you're trying to go solve for your users that will be unsolvable if this technology do not exist today. And a clear illustration is you have a point and shoot click system, a SaaS tool. It's clunky. It takes time to go through these workflows. You just presented them a unified natural language experience that solves the beeping and bopping between these different screens to just tell me what you want to get done, and I'll help you. I hope that helps. Marshall asks, why not pop list to point click select a particular device? Why force human to memorize IDs? Yeah, absolutely. That's just an illustration, Marshall. 100%, you should be able to not just simply ask for device IDs. You should be able to, if the API could easily adapt to present a list of devices. That's just a UI. It's just an illustration, easily adaptable to that scenario and to improve the user experience. Hi, ask from the look of it, Arch Gateway, that's calling the LLM and not the application server. In this particular instance, where we offer a convenience capability to summarize a response from a function call, it does call it. But it also exposes the ability to call large language models using a unified interface through the proxy for rate limiting reasons, for authorization reasons, for model selection reasons, for security reasons. And we have a lot of that in the documentation as well, and how you can use Arch Gateway, not just for the ingress piece, but just for the egress, if that's your primary use case. Being able to get logs and metrics in a consistent way, being able to store your keys in a consistent way, be able to route to different models based on goals and usage in a consistent way. So what I just showed was a convenience feature. So it just helps with demonstrating the full breadth of the capability, but you can actually call using an open AI client by configuring a certain port and IP that everything proxies through Arch Gateway. Okay. And then the last piece, if I'm not mistaken, is from Jamaluddin. Try the Google. Google Gemini API models are pretty good too, for sure. People should try them. Once again, model choice, the freedom to incorporate different models, the freedom to move between them is a really important theme in what we hear from developers as they want to leverage the strengths of something new that comes out. One of the key capabilities that you can push outside of application code and into application logic, configuration logic, is you can start pushing all that config out of application and simply centralize the ability to add more of these models. Now, naturally, you'll have to tie them with some ID, but besides that simple piece, or eventually based on usage-based routing, you wouldn't even have to do that. You can use different models and incorporate different LLMs for different task scenarios. Okay. For next question is from Krishna. I hope I got your name right. Krishna. For enterprise applications that focus on evaluation with some research, what are the AI patterns? What is recommended RAG or agentic framework? If agentic framework is autonomous and one controls, what is your recommendation? I really think it's about the task definition. If you really are trying to solve for, and if you think you have these three segments, hey, some users are going to ask for open-ended questions, and we need to be able to make sure that they have the rights to ask those questions, the authorization. You'll have to think about building autonomous agents where essentially you need a high-quality large language model with planning capabilities and reasoning capabilities to take an open-ended problem and direct it to something downstream process that can handle it. And this is why we invented prompt targets. Prompt targets is a higher level abstraction on essentially task routing with the convenience of being able to directly call a function if one exists. And so it depends on the task definition. If you're simply doing some Q&A on some documents and you know the usage patterns clearly well defined, whether it's multi-hop or single hop, you don't need, it's not an open-ended problem. When you're trying to do research, and this is a different type of prompt, of course, and you have to figure out how to think about prompt targets and prompts in specific. When you think about like open-ended research among documents to derive multiple insights, which is not simple Q&A, yeah, I think you need it. So it's scenario-based, and and you can go from little agency, which is basically a roadmap, to more agency to full agency over time. And that's why I presented at a spectrum, because you can build it as a roadmap for your applications, for your agentic AI applications. And in terms of recommendation, there's so many different ways to slice this. What I say is, if you understand the spectrum, if you understand the tasks well enough, and you can start designing experiences and measuring those experiences and build a roadmap. If you don't think you can solve a research problem, you can simply be able to, use some of the tools and technologies like Archgate to say, I'm only going to support certain scenarios. If you saw the demo, the first thing that Archgate did based on the config that it loaded was keep the conversation to 2 specific things. Now, of course, you may want to do 5 things or 10 things or 20 things, maybe not more, because you have a good. It's like you're building a UI for a SaaS tool. You're not just going to build an open-ended form unless you want that open-ended form to be the open-ended question that is handled and where you trade off latency and cost to do a very complex task. In that scenario, I mean, choosing the right model is more important than choosing a framework. I hope that makes sense.